Hello dear students, welcome back to my video lecture 2 on hydrogen and its compounds. See guys, in the previous video we started with dihydrogen, its isotopic forms, its position in the periodic table, and then we were talking about the different methods of preparation of hydrogen. What are the different methods of preparation of hydrogen? The first method is, when metals react with mineral acids, they liberate dihydrogen gas. When now amphoteric metals react with bases, they form dihydrogen. These two are the laboratory methods of preparation of dihydrogen. And after that I was talking about electrolysis of aqueous barium hydroxide, and then coal gasification, and also we have got one more important method, that is called as electrolysis of water. These three are the industrial methods of preparation of dihydrogen. I think I was talking about coal gasification. So in this video I'll continue with coal gasification, and we will go ahead with electrolysis of water. Students, now let us continue with coal gasification. I have told you in my previous video that when steam is passed over red hot coke, it gives a mixture of carbon monoxide and hydrogen. The mixed 1:1 ratio of carbon monoxide and hydrogen is called as water gas, I have told you. 1:3 ratio of carbon monoxide and hydrogen is called as syngas. But water gas and syngas are according to old convention, but according to new convention, any ratio of carbon monoxide and hydrogen, this is called as what? Syngas. Any ratio of carbon monoxide and hydrogen is called as syngas or synthetic gas. See, and this reaction is called as what? Coal gasification. See, in coal gasification we do not get hydrogen. Because carbon monoxide is a gas, hydrogen is also a gas. Since both of them are gases, we cannot separate hydrogen from carbon monoxide. Separation becomes difficult. So that means we cannot get hydrogen from coal gasification. Then what else I have to do? See, this syngas should again be treated with steam. Steam in the presence of iron chromate. In the presence of what? Iron chromate. When carbon monoxide, that is syngas, when it is again treated with steam in the presence of iron chromate, now this will give a mixture of carbon dioxide and hydrogen. When carbon dioxide is dissolved in what? Sodium hydroxide, it forms sodium carbonate, Na2CO3. So we will get pure hydrogen. Pure hydrogen. When carbon dioxide formed is dissolved in sodium hydroxide, hydrogen will not be soluble in sodium hydroxide. Only carbon dioxide gets dissolved in sodium hydroxide to form sodium carbonate. Therefore I can remove carbon dioxide and I can get pure hydrogen. Or else what else I can do? I can dissolve this carbon dioxide in water. When carbon dioxide is dissolved in water, it forms carbonic acid. It forms what? Carbonic acid. And hydrogen gas will not be soluble in water. So only carbon dioxide gets dissolved in water, we will get pure hydrogen gas, isn't it? See, this reaction, what is this? Conversion of syngas into carbon dioxide and water. This reaction is called as water gas shift reaction. water gas shift reaction. This reaction is called as what? Water gas shift reaction. And okay, so in this water gas shift reaction, I'll get carbon dioxide. That carbon dioxide, when dissolved in water, gives carbonic acid. Thereby we will get pure hydrogen. See, this method of obtaining pure hydrogen by dissolving carbon dioxide in water, this is called as Bosch method. Okay, this is called as what? Which method? Bosch method. Okay, what is it? Okay, no doubt I'll now pass steam over syngas in the presence of iron chromate. Okay, we will get a mixture of carbon dioxide and hydrogen. This carbon dioxide should be dissolved in water. Okay, so thereby we will get only hydrogen gas. See, this method is called as which method? Bosch method. Bosch method. So conversion of syngas into a mixture of carbon dioxide and hydrogen. This reaction is called as water gas shift reaction. Water gas shift reaction. Understood? Okay, that's great. Now let us go with another method of preparation of dihydrogen. The last method of preparation of dihydrogen. What is it? Electrolysis of water. Electrolysis of water. Electrolysis of water. We know when water is electrolyzed, okay, yes, electrolysis. What do you mean by electrolysis? Breaking the compound by passing current. Okay, electrolysis is breaking the compound by passing current. So when water is electrolyzed, it will give hydrogen gas and oxygen gas. Okay, hydrogen gas and oxygen gas. Hydrogen gas is produced at cathode and oxygen gas is produced at anode. Okay, isn't it? Hydrogen gas is produced at cathode and oxygen gas is produced at anode, isn't it? Look at the actual process. Okay, in the actual process, what is that we're going to do is, we will take distilled water. Okay, we will take what? Distilled water. Yes, distilled water. Why distilled water? Because it is the purest form of water. Distilled water. Okay, it is the purest form of water. Now we're going to dip two platinum electrodes. Which electrodes? Platinum electrodes in this distilled water. Okay, and we now connect it to high voltage battery. Okay, high voltage battery. Okay, these are platinum electrodes. Platinum electrodes. Okay, so we have dipped platinum electrodes in distilled water and those platinum electrodes are connected to external source of battery. So when we pass high voltage of current, look at what happens at anode. Okay, yes, the terminal, the electrode, the platinum electrode that is connected to the positive terminal, this is anode. Okay, and the platinum electrode which is connected to the negative terminal is what? Cathode. Got it? Okay, so what happens at anode? This water will get oxidized to oxygen gas. Okay, will get oxidized to oxygen gas by liberating how many electrons? 4 electrons. By liberating how many electrons? 4 electrons. I hope you understood. Okay, what happens at cathode? Okay, at cathode, water will get reduced to hydrogen. It will absorb 2 electrons, gets reduced to hydrogen. Okay, and it forms what? Okay, yes, 2OH minus. 2OH minus. See, observe here, number of electrons lost is 4. Number of electrons gained is 2. We have learnt it in redox reaction. Number of electrons lost must be equal to the number of electrons gained. So what I'm going to do is, I'm going to multiply this reaction by 2. Okay, if I multiply the reaction by 2, what I will get? 2 2s are 4. Okay, 2 2s are 4. 2 1s are 2. 2 2s are 4. Now, okay, add the two reactions. Okay, 4 electrons gets cancelled. 2H2O plus 2H2O is 6H2O, isn't it? 6H2O, is that correct? Okay, so it will be giving what? H2H2 plus O2. 4OH minus plus 4OH, 4H plus 4H plus 4OH minus is nothing but 4H2O. Okay, so 4H2O, 6H2O, they cancel. Okay, we'll be left with what? 2H2O to give 2H2 plus O2. This is the same reaction what we had written earlier. Okay, water is electrolyzed, giving rise to what? Hydrogen and oxygen. Hydrogen and oxygen. So that's about the preparation of water, dihydrogen, by electrolysis of water. Okay, this is one of the industrial methods of preparation of hydrogen. Okay, now let us talk about the physical properties of dihydrogen. What are the physical properties of dihydrogen? And then we will talk about different forms of hydrogen. Okay, physical properties of dihydrogen. Okay, physical properties of dihydrogen. Okay, observe. See, dihydrogen is a colorless, tasteless, okay, odorless, and combustible gas. It's a combustible gas. Okay, that is why, okay, it is used as a rocket fuel. Okay, upon combustion of hydrogen, it releases huge amount of energy. Okay, that is what I told you in the very beginning. Okay, on the surface of hydrogen, on the surface of sun, hydrogen will keep undergoing fusion, and it releases enormous amount of energy, isn't it? Okay, so it is a highly combustible gas. That is why it is used as what? Rocket fuel. Okay, yes, it's a colorless, tasteless, odorless, and a combustible gas. Okay, yes, it is liquefied. It is liquefied at very low temperature, and high pressure. Okay, and high pressure. The liquefaction of hydrogen gas is quite very difficult. Okay, it is very difficult. So it does not take place at ordinary or nearly ordinary conditions. It takes place at very low temperature and high pressure. At a temperature of minus 239 degrees centigrade. Okay, the temperature is around how much? Minus 239 degrees centigrade. Okay, got it? And observe. Okay, see, observe this. See, HH bond in hydrogen molecule. Okay, since hydrogen atoms are very small atoms, since they are small atoms, since they have very small size. Okay, yes, this bond will have high bond energy. It will have what? High bond energy. Okay, the bond energy of this bond is very high. That means you have to supply very large energy, very high energy to break this bond. Okay, now it is highly stable. Are you getting my point? Since the two atoms are small in size, okay, since they are smaller in size, the two atoms are very near to each other. Therefore, this bond is the shortest bond. Okay, since the bond is very short, it will be very strong. Okay, that means this has a very high bond dissociation energy. The bond has it is very stronger. Okay, if you want to break this bond, you have to supply large amount of energy. Okay, you should note this point. Okay, so I can say HH bond for hydrogen, the bond dissociation energy is very high. Bond dissociation energy is very high. Okay, so you have to supply a large amount of energy to break the bond between the two hydrogen atoms, since the two hydrogen atoms are smaller in size. Okay, and this bond, okay, if you compare the bond energy of HH bond to any other bonds, okay, for example, if I compare the bond energy of HH bond, okay, yes, with CH bond, or CO bond, or OO bond, NO bond, okay, NH bond, OH bond, okay, yes, HH bond, okay, this bond has very high bond dissociation energy when compared to all of these. That means HH, okay, the hydrogen molecule, this bond has very high okay, very high bond dissociation energy, okay, among all the bonds, okay, when compared to all other bonds. When compared to, you can compare this to CH bond, CO bond, OO bond, NO bond, NH bond, OH bond. Okay, when compared to all other bonds, the HH bond has very high bond dissociation energy. Since it has very high bond dissociation energy, this is less reactive. Okay, hydrogen is less reactive. Okay, are we clear? Hydrogen is what? Very less reactive. Since it has very high bond dissociation energy, you have to supply a you have to supply an energy of 439 kilojoules per mole of energy. Okay, you have to supply how much of energy? 439 kilojoules of energy in order to break this bond. Okay, you have to supply such a large amount of energy to break this bond. Therefore, hydrogen molecule is less reactive. Okay, so that's about the physical properties of dihydrogen now. Okay, now guys, let us talk about the different forms of hydrogen. Okay, let us talk about the different forms of hydrogen. Okay, what are the different forms of hydrogen, guys? Let us talk about the different forms of hydrogen. Okay, yes, see, hydrogen exists in two different forms. One is called as ortho hydrogen. The other one is called as para hydrogen. Understand this point here. Okay, yes, are you getting my point? Hydrogen exists in two forms. One is called as ortho hydrogen. The other one is called as para hydrogen. Okay, what is ortho hydrogen and what is para hydrogen? Okay, see guys, in an orbital, if an orbital has two electrons, then the two electrons spins in. Okay, now the two electrons will have different spin. If one electron spins in clockwise direction, the other electron will spin in anti-clockwise direction. If the two electrons have same spin, no. Okay, this is highly unstable. Okay, if the two electrons have same spin, this is going to be highly unstable. So this is not acceptable, isn't it? This is not acceptable, yes or no? Okay, so in an orbital, the two electrons must be in opposite spin. If one electron spins in clockwise direction, the other electron spins in anti-clockwise direction. Just like the spin of electron, even the protons will be spinning around their own axis. Even the protons will be spinning around their own axis. Okay, are you able to understand my point? Just like the electron spins in clockwise direction and in anti-clockwise direction, even the protons will be spinning about their own axis. Okay, now, just a minute. Okay, now look at here. So as I said, just like the electrons spinning in clockwise direction and anti-clockwise direction, even the protons will be spinning in their own axis. Okay, so observe this. Now consider the two hydrogen atoms. Okay, hydrogen, this is one hydrogen atom, this is another hydrogen atom. Okay, yes. Now, this is the nucleus of one hydrogen, this is the nucleus of another hydrogen. So there is one proton, and one electron. Look at here, if one electron is spinning in clockwise direction, the other electron will be spinning in anti-clockwise direction. Okay, on the same lines, just like the spin of electrons, even the protons will be spinning on their own axis. If the two protons are spinning in the same direction, observe here, if the two protons are spinning in the same direction, then it is called as ortho hydrogen. Are you able to understand? If the two protons spin in the same direction, if protons spin in the same direction, then it is called as ortho hydrogen. Okay, now look here, consider two hydrogen atoms and a hydrogen molecule. Okay, yes, this is the nucleus of one hydrogen atom, this is the nucleus of another hydrogen atom, this is one electron, this is one electron, okay, one proton, one proton. Okay, look here, okay, the two electrons are spinning in opposite direction. Okay, one electron is spinning in clockwise direction, the other electron is spinning in anti-clockwise direction. Just like the spin of electrons, there will be spin of what? Protons. And if the protons are spinning in opposite direction, if the protons, see this proton is spinning in clockwise direction, this proton is spinning in anti-clockwise direction. If the protons have opposite spin, if the protons have opposite spin, then that hydrogen is called as what? Para-hydrogen. If the protons have same spin, that is called as ortho-hydrogen. Okay, so what is para-hydrogen? Yes, okay, protons spinning in same direction. Sorry, protons spinning in what? Opposite direction. Okay, it is called as para-hydrogen. If the protons spin in same direction, ortho-hydrogen. If the protons spin in opposite direction, it is called as para-hydrogen. And you should remember that, okay, ortho-hydrogen is more stable. Okay, ortho-hydrogen is more stable than para-hydrogen. Okay, ortho-hydrogen is more stable than what? Para-hydrogen. Under low temperature, at low temperature, para-hydrogen is dominant. Okay, at high temperature or room temperature, ortho-hydrogen is dominant. Are you getting my point? Okay, at low temperature, para-hydrogen is dominant. Okay, at high temperature or at room temperature, ortho-hydrogen is dominant. Okay, but of course, ortho-hydrogen is always more stable than para-hydrogen. So that's about the different forms of hydrogen. Okay, so guys, so far we have discussed, okay, the preparation of dihydrogen, the physical properties of dihydrogen, okay, and the different forms of hydrogen. So in the next video, I'll be talking about the different chemical properties of dihydrogen. Thank you.